Hi, my name is Chris Brown. I'm the New Jersey Chapter Professional Development Officer, the Planning Webcast Series Coordinator, and a planner for the City of Hoboken. I'd like to welcome everyone to today's webcast, Complete Streets and Green Infrastructure. It's now 1 p.m., so we'll begin our presentation shortly. Today's presentation is co-sponsored by the APA chapters of Connecticut and New Jersey. There it is. For help during today's webcast, please feel free to type in your questions into the chat box located down at the right corner of your screen, or call 1-800-263-6317. For content questions, please feel free to type those into the questions box, and we'll be able to answer them during the Q&A segment at the end of this presentation. Here's a list of the sponsoring chapters, divisions, and universities whom I'd like to thank for making the Planning Webcast series possible. We have quite a few webcasts scheduled for the remainder of spring into summer. To get a complete listing of these webcasts, please visit www.utah.apa.org/webcast and register for your webcast of choice. We're now offering distance education webcasts to help you get your ethics and law CM credits. These webcasts are available to view at www.utah.apa.org/webcast-archive. You can now follow us on Twitter or like us on Facebook to receive up-to-date information on the Planning Webcast series, as sponsored by chapters, divisions, and universities. To log in your CM credits for attending today's webcast, please go to www.planning.org/CM, select today's date, April 13th, and then select today's webcast, Opportunities in Complete Streets and Green Infrastructure. This webcast is available for 2 CM credits. Today's webcast is being recorded and will be available on Monday along with a 6-slide per page PDF at www.utah.apa.org/webcast-archive. And at this time, I'd like to introduce today's speakers. Jim Riordan has been a project manager with Fuss & O'Neill since 2005. He coordinates the Providence Office water quality programs. Previously, Jim worked at the Rhode Island Department of Environmental Management. During his 12-year tenure, he coordinated the Rhode Island nonprofit non-point source pollution management and financial assistance programs. In 2005, he received the EPA Environmental Merit Award for his work on smart growth and stormwater programs. In 2011, he received the Rhode Island Chapter American Planning Association President's Award for his work as chairman of the Southern New Planning Conference Committee. Wade Walker, professional engineer, is the Director of Transportation Planning for Fuss & O'Neill. For the past 17 years, he has focused on the restoration of livability to streets, smart growth, and walkability. His work primarily involves leading the transportation planning efforts for a variety of projects and clients, often in an intensive design charrette setting. Wade has been involved in many varied initiatives, concentrating on livable traffic and the rebalancing of modes, ranging from downtown revitalizations to new traditional neighborhood developments to preservation of scenic and historic roadways, and design and implementation of complete streets and thoroughfares. Recent projects include the US 64 Parkway Alternative in Bolivar, Tennessee, Mountain Landscapes Initiatives in Western North Carolina, City of Raleigh Unified Development Ordinance and Street Design Manual, El Paso Avenue Complete Streets Design in Russellville, Arkansas, and Overton Broad Connector Cycle Track in Memphis, Tennessee. In addition, Wade has presented papers on context-sensitive design at national conferences for the Congress of New Urbanism, APA, Institute for Transportation Engineers, and the Transportation Research Board. Kathleen Caren is an open space coordinator for the County of Passaic Planning Department. She is involved in open space preservation, park development, and redevelopment, as well as farmland and historic preservation. Prior to this, she advocated for an open space trust fund in her hometown and was subsequently appointed to the Open Space Committee and named chair. In 2004, she was hired as Passaic County's open space coordinator. She provides staff support and expertise to the county Open Space Advisory Committee and had previously also been the administrator for the County Agriculture Development Board. She thoroughly enjoys her work. Amy Rowe is the Rutgers Environmental and Resource Management resource management agent for Essex and Passaic counties. Her outreach programming has focused on green infrastructure in urban environments and green jobs training programs. Prior to coming to Rutgers, Amy worked at the Environmental Protection Agency's Urban Watershed Management Branch in Edison, New Jersey. At the EPA, her research focused on runoff from sealed asphalt surfaces and on the monitoring of a permeable pavement demonstration site. Amy received her PhD from Rutgers in Environmental Sciences. Virgil Lloyd has over 30 years experience in wastewater engineering. He leads the water and wastewater practice at Fuss & O'Neill Incorporated, which is a multidisciplinary engineering consulting firm headquartered in Connecticut. He is a licensed professional engineer in several states in New England. His areas of expertise are wastewater treatment, disposal, and conveyance systems. His focus in recent years is assisting communities develop proactive wastewater management strategies that are sustainable for the long term. So as you see, we have a good number of speakers today, and we're going to have a longer than usual presentation. So I just keep in mind that we will be going up until 3 p.m. with this webcast, whereas usually we end at 2:30. The good news is we get an extra half hour of credit. So good times. So with that said, I'm going to hand over the presentation to Jim Riordan, who will start us off.
Hello, everybody. I'm Jim Riordan. I'm from Fuss & O'Neill, and I'm an AICP planner. I'm going to speak today about stormwater green infrastructure. I'm going to focus particularly on standards that were developed in Connecticut, and then some implementation work that we've been involved in the town of Warren, Rhode Island. Begin with the development of new low-impact development standards for Connecticut, specifically for the Connecticut Department of Energy and Environmental Protection. And then I'll move on to a project that I call the Greening Water Street, which, as I mentioned before, is in Warren, Rhode Island. The objectives for low-impact development policy update in Connecticut were to build low-impact development into their stormwater general permits and their policy. Specifically, their policy, two policy standards books, the Connecticut Stormwater Quality Manual, and the Connecticut Guidelines for Soil Erosion and Sediment Control. The Connecticut Department of Energy and Environmental Protection wanted this to be a partner-driven process. It was very important to them that the folks who are in the regulated community were going to be well aware of what the standards were, how these standards were going to get implemented, and was essentially, these groups of folks were essentially on board with what was going on. First task in this process was to develop a list of partners. We developed a list of over 50 diverse statewide partners to work with the Department of Energy and Environmental Protection to review and incorporate low-impact development into their stormwater general permits. The reason that they were focusing on a wide, diverse group of partners was experience that had happened in a couple other states, particularly over on the West Coast, California, Washington, where it had been attempted to bring low-impact development into general permits and to statewide standards, and there have been some very serious objections on the part of the regulated community that in some cases were threatening lawsuits. So Connecticut was working to try and avoid that process, that problem, essentially short-circuit the issue or stop the issue right before it starts by working with partners up front. So we We worked with them to identify a list of partners that included folks at the federal level, EPA, other folks at the Department of Energy and Environmental Protection, also at the state level, their Department of Health, their DOT, various folks from the building community, as well as municipal partners, watershed partners, and other nonprofits. We ran 6 partner-centered workshops, which really were intended as opportunities to facilitate input from the partners. This is an example of the way that we got the word out on this particular project. We used a web page that was hosted by DEEP, and it contained essentially all the project information from each of the workshops, as well as background on the project. We also included all of our deliverable products for the project on this web page, and in this way it was very easy for the Department of Energy and Environmental Protection to before a workshop or at the end of a workshop send out an email to each of the folks that have been involved, each of the folks that was on their partners list, and say, you know, there's new information that's been posted and you can find it at this location, and people could easily download it and, you know, of course, make comments back to the department. If you're interested in seeing this web page, it's still up on their website, and you can find it in one of 2 ways. If you like typing, you can put in the nice long URL that's up at the top of the page there, or you can just simply Google it by typing in CTDEP or DEEP. The department changed its name partway through this project. LID evaluation, and it'll come up as one of the first couple of search items. A major deliverable for this project was the development of specific guidelines for low-impact development. Previously, the department had included some essentially narrative information about how to use low-impact development in some of their policy books, including the Stormwater Quality Manual. But this actually included a little bit harder and faster standards, design standards for how you build a low-impact development best management practice. 2 appendices were developed for their stormwater, one for their stormwater manual and one for the soil erosion sediment control handbook. Those are both available on the web page that I just showed you, or you can pull them up directly by typing in the URLs that are listed on the screen. Next, I'm going to talk about a project that involved the use of low-impact development BMPs, and this project was focusing on retrofit of low-impact development BMPs into an existing roadway and an existing developed area. So these were not things that were being brought in as part of construction of, say, development or subdivision or something like that. This was actually taking an existing roadway and finding ways to retrofit in low-impact development BMPs. This project also involved traffic calming, and in this way also fits in with discussion that you'll hear a little bit later on complete streets. The reason for doing the project initially was to address quality at the town beach in the town of Warren, Rhode Island. And that beach had experienced a significant number of closures over previous years. And the idea here was to try and abate those closures. So at the start of this project, it was unclear what was causing the closures at the beach. The town had previously slip-lined a storm sewer main, or not a storm sewer main, excuse me, a wastewater main and had felt that they had closed off that as a potential source of pollution. However, there was some disagreement about whether that had happened to an adequate extent or not, or whether maybe that lining was failed or hadn't been done properly. So we were asked at the start of this project to identify what the potential sources were. We identified potential sources including that sewer main and stormwater as the main potential sources in this area. In order to determine to what extent these sources were affecting quality at the beach, we did a series of dye testing, dry weather sampling, and wet weather sampling of groundwater and stormwater and beach water to try and figure out, really nail down what the source of the problem was. And as a result of this, we determined that that sewer lining was in fact not working properly, that it might make sense actually to replace the sewer in its entirety, since the sewer lining had not seemed to work the first time around. We also noted that stormwater was a problem in the area, and that a good way to address stormwater would be through green infrastructure, and that it would make sense, since the road would need to be pulled up in order to put in the new sewer line, to replace the sewer line, to address pedestrian traffic conflicts that were existing between a park that you can see on the right-hand side and the beach that you can see on the left-hand side of the picture on the screen. So we pulled together a scope of work and identified specific goals. Specific goals were to reduce pathogens at the beach, better manage drainage through green infrastructure, better manage wastewater through the replacement of the sewer pipe, improve beach water quality, and also improve traffic management. We started it with an initial phase of the project that included feasibility study of these three main issues: the stormwater, the wastewater, and the traffic management. Following that, we did a second phase of the project, which was a more thorough design and permitting. During that, which occurred a couple of years ago, we determined that the site might contain some very significant historic artifacts. As it turned out, it was a Native American burial ground at one point in time, and so that delayed moving forward with construction of the project. We're expecting that to happen later this year. But through this process, I think we probably come up with a better design approach. We worked closely with neighborhood folks in the area to really try and come up with an approach that would work well for them in terms of managing the traffic and in terms of using stormwater infrastructure that would be aesthetically pleasing to them. Oops. Here is before and after of the site. As I mentioned, it's not constructed yet, so this is a virtual before and after renderings, essentially. So you can see the proposed view up on the top and the existing view on the bottom. The street in the proposed view will be lined with bioretention. It will also include traffic management such as raised walkways. These raised walkways will be textured and dyed so that they have the look of brick, which will make them look nicer. Will also stand out better and discourage, essentially high-speed traffic in this area. We've also included pervious pavement in the park area, and so you can see that folks who would come to the beach would be able to park in the parking lot and directly walk across a raised area that was pretty well demarcated, so that the traffic would be able to see and would know to slow down. and stormwater would be managed as well. You can't see it in this particular rendering, but closer to the entrance of the beach, which is in the background a little bit, there will also be a drop-off location so that if you have young kids, you can drop people off close to the beach. That was actually something that came out of the neighborhood meeting. Financing for Water Street. Important aspect of any project is, of course, being able to come up with financing for it. And as is the case with most municipalities, the town of Warren, Rhode Island was not made out of money and needed to look to external sources to potentially gather some funding. The initial stormwater or wet weather and dry weather studies that we did that identified the sources of pollution were funded directly through the town. Those amounted to about $20,000 up front. The town was then able to leverage an existing non-point source grant, or a 319H grant, sometimes people refer to them as that they had, reprogram that to work specifically on this project. It had been actually taken for another purpose, but it was close enough to this that they were able to reprogram it. Develop a feasibility approach that we were then able to review with the town staff and later the neighborhood in charrette-style meetings. And then ultimately they were able to take the results of the design work that was done from this and bring that to the Rhode Island Department of Environmental Management and request an SRF loan. They received authorization for an SRF loan of $3.3 million. It was partially an ERA grant. I'm sure you guys will remember those from a couple of years back. And it was specific for green infrastructure. Because of the low-impact development BMPs that we had included, this became a green infrastructure project, which meant that they got a much better loan rate on this, and they actually got principal forgiveness of 13% of the total principal on the project. So it's essentially a partial grant, partial loan, if you want to look at it that way. A couple of key points here about what made this project attractive to funders and to move forward, I think, in general with the town. Clearly documented pollution problem. All that work that we had done up front, sampling and determining what the sources were, really made this an easy-to-explain project to the general public and to potential funders. The importance of the water resource in this area. As you recall, this is a town beach. It's a town beach that had experienced significant closures. It's obviously an area that folks wanted to restore to its original quality or desired quality. Clear implementation approach. We developed plans and designs up front that we were able to show people and show exactly what it was that we wanted to do and when, and the kind of buy-in that we had on the project. Demonstration of low-impact development for Green Street. This is actually one of the very few green streets that have been implemented in the New England area. I believe it'll get built most likely this summer. I believe it'll be the second one in New England overall. So demonstration of this kind of approach was something that I think was very attractive to funding agencies. And then general agreement amongst stakeholders. We spent a lot of time working with the neighborhood, working with state and municipal authorities, and also with the Native American constituency in this area, as well as federal groups, to make sure that everybody was on board with this and that this was going to be a successful project. With that, I'm going to turn speaking over to Wade Walker.
Okay, thanks, Jim. And my topic today is complete streets. and I like to refer to it as making room for everyone, because when it really gets down to it, complete streets is not just about moving cars. It's about moving people, and how do we move people to their destinations. Something that we seem to have lost track of in recent years, because if we look at a lot of our older cities and older downtowns and fabric, we've known how to build really great communities from pretty much the time that we've been building communities. So what happened? Well, it's the four-wheel vehicle and the freedom that was associated with it, and all of the unintended consequences that came along with the car. The car in and of itself really didn't cause the issue. What really did was that we, and I'm including we because I am a traffic engineer, we actually started accommodating, not only accommodating, but basically designing our transportation facilities for the automobile, not necessarily to move people, but to move vehicles as quickly as possible, as if nothing else mattered. We started emphasizing things like capacity, efficiency, this level of service for the vehicles, and making sure that we minimized vehicle delay. What one of those consequences is that we've really made it very, very difficult for people using these facilities as well. And we've even gone to the extent that sometimes in design guidelines, some of the things we saw was that you couldn't build a road that had a speed limit lower than 45 miles an hour. We couldn't have lane widths less than 12 or 11 feet. We even went through a period where we were not building two-lane roads. Two-lane roads were just simply not good enough. If we needed additional capacity, we needed to do it then. We stripped roads of on-street parking in the name of throughput, as well as removing street trees, furniture, and thereby pedestrians, all in the name of clear zone requirements. So how have we started getting back to it? Well, the public has spoken, and people want to live in walkable communities. They want walkable areas. Our guidelines, a lot of the state and local design guidance did not allow that to happen under design standards. So what we've now done is, through the efforts of collaborations such as the ITE and Congress for New Urbanism, we've come up with sets of guidelines that are specific to these walkable urban areas. Whenever we try to apply highway standards in these urban areas, we fail miserably from a people standpoint. Do a great job in moving cars, but that's pretty much all. So a few years back, Institute for Transportation Engineers and the Congress for New Urbanism got together and decided to develop a set of guidelines that really go toward helping us build walkable facilities in more urban areas. And the slide that you're seeing is a result of that, the recommended practice, designing walkable urban thoroughfares, a context-sensitive approach. And it really does go back to recognizing one of the basic tenets that was often overlooked in our national design guidance, the AASHTO Green Book. In the preface, it tells us very clearly that we as traffic engineers should be designing to context and to the surroundings, and that other things do matter, such as community and the natural and built environment. But this guidance goes a little further in actually giving an engineer or a designer some guidance as to how to actually accommodate and build walkable kinds of infrastructure within communities. What that's all led to is the whole idea of complete streets. And we hear the term a lot in our practice, but whenever you really boil it down to its simplest element, complete streets are really streets for everyone, regardless of if they're on foot, on a bike, using transit, or in a car. It really is about making it easy for all the different modes, both motorized and non-motorized, to coexist within the shared open space in the greater realm of a community. we're really seeing the whole idea of complete streets mirrored in our emerging transportation philosophy, because most projects now are getting done with these thoughts with these thoughts at a forefront and as one of the guiding principles. So, complete streets really are about livability and balance. We understand now that we really need to focus on integrating the land use and the transportation improvements. We want to make sure that things are seamless, not only from a street network standpoint, but as you cross modes, so people can catch a bus, they can easily walk to where they're going, they can put their bike on a bus, or utilize a park and ride network and be fully interconnected through all of those. We also want to make sure that we use the inherent flexibility in roadway design so that we can build facilities that blend into both the natural and built environments and don't scar it. And finally, the last bullet point, we've really come more about doing the design out of the vacuum, out of the cubicle, being more collaborative, interdisciplinary, and bringing the community into the kitchen as these projects are designed. So whenever we boil it down, complete streets really are respect the overall context. They're very well connected. Again, not just from a roadway network standpoint or connectivity for one mode, but connectivity between modes. Really want to eliminate those seams if we can. We go beyond the travel lane, go beyond the pavement, think beyond the curbs, and really start to identify these different realms and enhance these different realms and tailor them to each of the users, whether they're motorized, non-motorized, walking, biking, buses as well, and make the interfaces between all of those much more seamless. Because at the end of the day, what we found is that really the size and the character of the road just really defines the overall urban environment. This is a street that's in serious need of traffic calming, but people still want to be able to walk from destination to destination. And so the principles of complete streets really allow those kinds of things to happen. One of the other things that we start to look at within the component of a street is to really start to look at how do people feel comfortable on a street. So it really is about getting the vertical and the horizontal distances correct, because really people want to feel enclosed. And by really addressing the height of the land uses on the street edges and making an appropriate size street, you can really start to make people feel a lot more comfortable within the space. We're doing a lot of this through integrating the transportation engineering along with the land use in the realm of form-based coding as well. And again, it really does start to come back to respecting the overall context. A road in a very rural area should and will be very different than one in a much more urban area. It's not to say that one can't adhere to the principles of complete streets, because they certainly all can. It's just how you meet those criteria can be different depending on where you are within a transect. And some of the ways that we actually are able to integrate and implement these kinds of streets are through land development ordinances and form-based codes. We do actually code street typologies right into a lot of our code work. In that we want to make sure that these different typologies really do respect and respond to the overall built and natural environment. We definitely go beyond the arterial, collector, and local street functional class. We're looking at many tailored kinds of classifications of roadways that have flexibility built into them for the land uses adjacent to them, but all of them we want to make sure that we do incorporate principles of walkability and complete streets in those as well. So again, really looking at the different zones on the street side to be able to provide those spaces as well. And the street side spaces, we make sure those are right into the design because we do look at the overall holistic streetscape. So we define these zones, so from a transition zone from the vehicle space to an amenity and furnishing zone, to the walking zone on the street side, and then to a frontage zone where people can shop or dine outdoors and interact with the rest of the community. But to do that, we do have to make sure that we are inherently walkable and that we're not creating conflicts between motor vehicles and the pedestrians. We want to make sure that they're as safe as possible, and we want to make sure that within these zones we provide for closing those gaps between walking and motor vehicles and other modes of transportation. So we want to be sure that we can provide bike parking, we can provide a transit interface, we give people a place to park, and even looking at configurations on parking, such as the example shown in the left-hand bottom photograph, which is a back-end angle parking. So again, really starting to enhance those different streetscapes and zones, and not discounting the use of materials to be able to define and highlight those realms. One place that we've really come a long way in the past few years is through our design of bike facilities, and really recognizing the bicycle as not just a recreational mode of transportation, but a viable form of transportation for commuters as well. Some guidance that we've recently received from the bikeway design groups, from the National Association of City and Transportation Officials, NACTO. If you haven't seen the NACTO Urban Bikeway Design Guide yet, I suggest that you check out their website because it gives us some great guidance on the range of facilities that we can incorporate to provide for bike facilities. It really does go beyond bike lanes and signed routes. We can now use sharrows. A lot of cities are starting to experiment with cycle tracks, and it's cities outside of the realm of the rarefied airs of Portland, New York, and D.C. Even smaller cities are doing that, and we're finding ways to actually use investments or reallocate assets such as drainage corridors or utility corridors to create more urban multi-use trails as we can. We've also changed our thinking somewhat with regard to vehicle travel lanes. We know that it's kind of interesting that traffic engineering is one of the only math-based sciences where 1 + 1 does not necessarily equal 2. 4-lane road cannot carry as much traffic as 2 separated 2-lane roads. So it really allows us to explore some things like the 4-lane undivided to 3-lane divided road diet with very similar road carrying capacity and much higher safety and ability to reallocate that pavement asset for other uses such as bicycles. And we also know that by reducing lane width, we can also reduce speeds as well. Because whenever we really get down to the safety factor, the biggest issue is the vehicle speeds. As a pedestrian, if you're struck by a vehicle at 20 miles an hour, you have about an 85 to 95% chance of survival. That drops to 15% when you double the speed of the vehicle. And it's kind of like Usain Bolt running right at you in lane number 4 and running right over you. You can imagine what kind of collision that would have. So another element of the complete streets is the idea of getting medians, landscaping, streetscape, and these are golden opportunities to dovetail into more green streets principles, rain gardens, bioretention, bioswales, and we're seeing that kind of use started in a lot of places. And then again, we want to make sure that we certainly accommodate all of the other issues, transit, freight, certainly emergency vehicles. Fire departments are learning that they can downsize vehicles and get more multi-use to serve some of these areas. And then really making sure that we handle our transitions, understand our maintenance, and make sure people know where to go with wayfinding. And one of the ways we put it all together, again, is through the idea of coding. And whenever we put all these elements together, we can certainly come up with really, really great streets. So who's actually doing it? I'm showing some slides here of some unusual suspects. Charlotte, of course, is generally recognized as one of the leaders in doing complete streets. But certainly New Haven, Connecticut is taking it to the nth degree with actually taking down a freeway and reconnecting the street grid with the Route 34 downtown crossing project. Some others, other larger cities that have not necessarily been known for walkability or complete streets. Memphis, Tennessee is really becoming one of the at the forefront of this bicycling movement. Memphis is on track to be one of the first cities in the southeast to actually do a cycle track project, do a two-way cycle track to connect connect their largest urban multi-use trail to their signature Midtown park in Overton Park. And then some of the other places, some unlikely candidates. Russellville, Arkansas, small town of 20,000, about halfway between Little Rock and Fort Smith on the I-40 corridor, is actually doing a complete street project to connect their university with downtown on the heels of a downtown master plan. That would be a cycle track and would actually use the separators from the travel lanes as rain gardens to actually assist with stormwater. So how do they get it done? Some of the funding sources that can be available, certainly a lot of places that we're working are using things like tax increment financing, business improvement districts, targeted sales tax, or even local option sales taxes to do these kinds of complete streets pieces. Voter-approved bonds are certainly a mechanism by which Charlotte does most of theirs. There's actually private foundations that, such as Bikes Belong, that offers both financial and technical assistance to communities that are trying to do these kinds of things. And then there's also federal grants and funding programs. And one of the things that we're seeing is the idea that communities are using their local funding sources as leverage for matching the grant, the federal grant application requirements. And finally, the idea of public-private partnerships on any kind of larger scale development-driven initiative are certainly ways to get that done. So it's an exciting time to be a traffic engineer working in complete streets. And I certainly appreciate your attention. Look forward to any questions, and I will turn it over to Caren. Or Kathleen, rather.
Hi, everyone. We're going to talk today about the Molly Ann Brook Watershed Management Plan implementation. We were honored last fall with an award from the New Jersey chapter of the APA for plan implementation of the Rain Barrel and Rain Garden initiatives. So a little background history. The Molly Ann Brook is a tributary that runs through a highly urbanized area of northeast New Jersey in Passaic County. It's a highly impervious, typical watershed, urban watershed. We were actually funded to prepare a watershed management plan because the Molly Ann Brook watershed was identified in 1996 as an impaired, polluted waterway, and most of the stormwater runoff, pollutes the Molly Ann Brook, which eventually drains into the Passaic River. Runs through these municipalities. North Haledon is a more suburban, rural area, but the other three are highly urbanized. So the question, can the Molly Ann Brook be improved? And the resounding answer is yes. The watershed management plan identifies several best management practices, and we decided to implement 2 of the non-structural. The goal was to enhance, protect, and restore the surface water quality of the Molly Ann Brook and its tributaries. So again, the 2 that we chose, these non-structural best management plans, were funded after the management plan had been approved by the New Jersey Department of Environmental Protection. We applied for another 319H grant, that's Clean Water Act funding, to purchase rain barrels for distribution free of charge to residents within the Molly Ann Brook watershed. So as you know, rain barrels capture rainwater that would otherwise just run off the roof and run into the storm drains and then eventually into the waterways. It is non-potable water, but it can be used for watering your lawn or your garden, washing your car, washing your pets, or any other uses. I've used my rainwater at home to mix cement if we have a little cement job to be done. Rain barrels really retail for more than $100. I mean, I've seen them up to, $200, nearly $300. And these were being distributed, again, free of charge, funded through this 319H grant through the NJDEP. They're easily installed, and as you can see in the pictures, they have a drain plug, they have a spigot, they have a screw-on lid, and a mesh screen, so you don't have to worry about getting debris or mosquitoes or mosquito larvae. We began, prior to actually receiving the rain barrels, we had distributed flyers, we had press releases in the paper, newspaper ads, we had information on the municipal and the county websites, we did have public meetings, and we had a watershed ambassador who was also working on classroom demonstrations. They were distributed again to these 4 municipalities at no cost to the residents. We have 2 paid interns through the grant who have worked very closely with the residents who've received the rain barrels, and they monitor and they address any concerns that the recipients have. So we also were able to get information from Rutgers Water Resources program on where to target our rain barrels. As you can see, the second distribution was the largest because that was the one that was advertised. The first distribution was just targeted to those people in North Haledon, which is, again, a more suburban area, but hilly. So the water, would rush down, and we wanted to make sure that those folks had rain barrels installed. And to date, I believe that we've distributed probably about 610 rain barrels. And then this shows which municipalities received the most. And Paterson is it's not the entire city of Paterson, just a small section. So they did not receive as many, but again, North Haledon. This shows this is the information that we got from Rutgers using their GIS. telling us where to target, and this is what was created here at the planning department, showing where the barrels are located, so it makes it easy for our interns to go out and check and, you know, interact with the residents. Here's an example of multiple barrels that are connected so that when one is full, it'll overflow into the others. I'm hoping that we get some rain soon because it's been pretty dry here in New Jersey. So the benefits to rain barrels are, again, reducing runoff pollution. They save your money on your water bill. We did receive feedback from gardeners who said that the gardens that they watered with rainwater grew better than the stuff that they were growing in their tap water. Provides water during the drought conditions. And it actually seemed, even though this wasn't our purpose, it seemed to reduce localized flooding from major storms. The environmental education aspect to local students was key. Kids would go home and talk to their parents about them, and it was like the kids were really pushing their parents to go pick up a rain barrel. And we are hopeful. We've seemed to be getting a signal from the NJDEP that they would like to implement this program as a statewide program throughout the state of New Jersey, especially in those urbanized areas. And our recipients have seemed to be more interested now in little changes that they can make to improve their environment. I'm going to turn this over now to Amy Rowe to talk about rain gardens.
Hello everyone, I'm Amy Rowe. I am the Rutgers Cooperative Extension Agent, Environmental Agent for Essex and Passaic counties, and I've been working with Kathleen at the Passaic County Planning Department for a little while now, and one thing that Kathleen didn't mention is that the grant with the rain barrels was so successful that the DEP had actually given extra money to implement a second best management practice for stormwater. And so this is actually phase 2 of the whole project, and so we were tasked with installing rain gardens around the Molly Ann Brook municipalities. And so I just want to give you some background on what is a rain garden. Some people know them as bioretention areas. They're basically just shallow landscape depressions that can capture, treat, and infiltrate stormwater before it even becomes runoff. So you're handling that stormwater at the source. And so one of the great things about rain gardens is that you have a beautiful addition to your landscape while also capturing stormwater runoff, so reducing stormwater quantity, but also improving water quality. And so you can see here from these pictures that the garden doesn't have to look fancy or anything like that. No one even has to know that it's a stormwater best management practice. It just looks like a regular garden, and it can take the feel of any kind of garden you want. It doesn't have to look completely natural. Some people like the naturalized look. Some people like the English garden formal look. So all of these gardens can be customized based on what plants you put in there and how you want your rain garden to look. But the water can be introduced into the rain garden through several avenues. It can either be piped in from a downspout. It can be at the bottom of a swale that's transporting water from a roadway or a parking lot, or it can be right next to a curbed area, and you can just have a curb cut with the water going into the rain garden. So as I stated before, the benefits of rain gardens are that you are handling stormwater volume so that you have reduced stormwater quantity in your storm sewer system, which leads to reduced stormwater going out to the receiving body. But you're also improving the water quality of the stormwater as it's moving through the different layers of rain garden. So plants can uptake certain pollutants, then the different layers of the soil can actually filter out pollutants as the water moves through from the top layer down into the native soil down below. And rain gardens can also be a great way to recharge groundwater, which provides base flow to our rivers and streams, especially during dry periods. But the rain gardens are very efficient at removing some pollutants. They have very high pollutant removal efficiencies for solids, for metals. Even some organics can be removed by rain gardens because of microbial activity. And the jury's still out on nutrient removal. There are some specific designs for rain gardens to help remove nitrogen and phosphorus, but a typical unengineered rain garden may or may not be helpful at removing pollutants. But a rain garden can also be used to prevent, to prevent wet spots elsewhere on the property. You don't want to install your rain garden in a wet spot because that means that you have poor drainage or some other kind of water issue there. So you don't want to put the rain garden on the wet spot, but put it further up to capture some stormwater to prevent the wet spot further downstream. Another benefit of rain gardens that's not listed here, but you can see the picture with the butterfly there, is that rain gardens can introduce habitat for wildlife, for pollinators, bees, birds, all kinds of things would gravitate towards your rain garden, which is a very exciting benefit in areas that may not have a natural landscape, like a very urbanized area like we have here in New Jersey. Okay, so here's just a quick schematic of the different parts of the rain garden. In the center of the rain garden, you have the base, which is completely flat. You need to have a very flat drainage area for the stormwater to infiltrate at the maximum capacity. If you don't have a level base, then you may have pooling, you may have ponding. You don't want your rain garden to be standing water. You don't want this to be a breeding ground for mosquitoes. You want the water to be moving through there as quickly as possible. You really want to have this rain garden drained within 24 to 48 hours of a rainfall event. And so that base needs to be flat, so you have the largest surface area possible for the infiltration. And then there's a sloped area around the base that you can put plants that don't like it quite as wet, but still would be receiving some water, whereas in the base you would want to plant plants that are possibly facultative wetland plants, not completely obligate wetland plants, because you don't want to have this rain garden be a wetland. It's not going to be wet all the time, so you need to have both wet-tolerant and drought-tolerant species in the rain garden. And then on the outer edge, you have the buffer, which is just a higher ground area that you can plant plants that don't necessarily like any water, but just so you still have some vegetation on the outside. And you can also see here that there's an inlet and an outlet. The inlet is where the water will be entering the rain garden, and then you do want to install an overflow or outlet so that if you have a very large storm event, let's just say 8 or 9 inches like we had this past fall here in New Jersey with the hurricane, you don't want all of that water to be standing in your rain garden. You want that overflow to allow that water to be released from the rain garden. You can either connect the outlet to the existing storm sewer system, or you can have it go out to another permeable area like a different section of a lawn. And you can also see that the typical depth of the rain garden is only 3 to 8 inches. You don't want this to be a pond. You don't want to have 2 to 4 feet of water in there. It's really just a very mild, shallow depression, which also helps with the safety issue. You don't have to worry about kids getting in here and drowning or anything like that. It's a very shallow system, which a lot of people think a rain garden has to be deeper than that, but that's not the case. So I'll turn it back over to Kathleen for the conclusions here.
So this is the Rain Garden Initiative is an ongoing project. We will be installing, I think, 5 or 6 more rain gardens this spring on public property. And again, Amy was very helpful in gathering data and showing these very impressive results. We had over 600 barrels prevented nearly 2 million gallons of stormwater from directly entering the watershed. And the 3 installed rain gardens will treat a total of 50,000 gallons of precipitation per year. And of course that will increase as we continue to install these rain gardens. And yes, thank you, Amy, for reminding me about, we had originally applied for a $70,000 grant from the New Jersey Department of Environmental Protection, and they liked the idea so much they gave us $100,000. So we were able to buy many more rain barrels, got them at a discounted price, and so when we had funding left over, we were able to shift the budget and modify the scope of work to include the rain gardens. So, and the rain gardens people have been so thrilled with them, and they're very attractive, and they're doing a really good job. So finally, I'd like to thank our freeholders and the administration for their support. Of course, the EPA and the DEP for funding the plan and also this implementation. Amy has been really significant and very helpful in this whole process. Chris Abrupta at the Rutgers Water Resources Program and his staff, very helpful. My colleagues, Jennifer Gonzalez, who's the environmental planner, and Rich Ferrigno, who's our GIS specialist. We had student interns, Faith Justice, Tariq Islam, and Jillian Polenta-Rudy. And the AmeriCorps volunteers, as I mentioned, they were helpful over the last couple of years. And all of the residents who participated and the municipal officials. If I go back just one more slide, I'm sorry, I didn't mention, if you would like to look at the watershed management plan and all the appendices, it can be found at our website there on the bottom, and I understand that all the attendees will be receiving a PDF of these, so you don't have to write that down. Thanks, everyone. I'm going to turn it over to Virgil Lloyd now.
Okay, I am unmuted here. So let's see. Can folks see my presentation? And we'll get started. Okay, so we're going to talk a little bit about wastewater in complete streets, which is sort of a kind of an odd component, I guess. But it is actually an aspect, I think, of when we think of development of really of any nature. I think over the years I've seen over my career, I've seen that the wastewater often was not a integral component in the original planning, and there, with our trends to away from, like, over the last 20 years of rather more sprawl type of development, there really wasn't an issue. People would, at least around here in Connecticut, where most of my work has been, we've seen a big 2-acre, kind of residential lot type subdivisions, and no one really worried too much about the wastewater. But there are issues out there, and I think it's really important to think about ways that we can integrate this into our developments, whether they're urban, suburban, or village type of settings. So with that as a see if this will move forward for me. Okay, so the topic I'll be covering here today I'm going to try one more time. There we go. Okay, good. Okay, so the topics I'll be covering here today, I'm going to cover kind of the whole spectrum of wastewater types of settings. I'm going to first talk a little bit about some decentralized wastewater approaches and a couple of case studies there, one in Old Saybrook, Connecticut, and another in Greenwood Lake, New York. Then I'm going to look at some opportunities for efficiencies and for green infrastructure with more traditional, classic, large wastewater treatment facilities, and things related to nutrient removal and carbon and other ways to dispose of the wastewater than what our current practice has always been. And then finally, I'll look at some green opportunities themselves within the different wastewater facilities. So with that, first off, in wastewater, probably most people think, oh, what's so green about wastewater? Well, actually, wastewater is pretty green, and there certainly are some opportunities here. The U.S. EPA definition, when you're talking wastewater, it's these 4 categories here. It relates to energy efficiencies, which really relates to the equipment. A lot of equipment, of course, pumps, motors, are used at treatment plants and in pumping facilities. So there's opportunities to use higher efficiency types of equipment, and that's one of the recognized areas. Innovative or decentralized types of solutions is such as what I'm going to talk about with Old Saybrook. Decentralized meaning a solution other than a centralized treatment plant. It's kind of the opposite of the big pipe. Probably some of you, I'm sure, have heard of that. And then utilize some low-impact design techniques, such as Jim and Kathleen and Amy have talked about a little bit. And hopefully that's intriguing. How in the world can you use that with wastewater disposal? Talk about some things that people are doing with that. And then even renewable energy. There is a lot of energy in wastewater. That's the 4th category.
Hey, Virgil, I'm sorry, it's Chris Brown. I just wanted to let you know that we're getting some comments that your audio is a little bit going in and out. So just wanted to let you know about that.
Okay.
Some people are having a hard time hearing.
Okay, hopefully this is better. Sorry about that.
No problem. Thank you.
All right. And then lastly, I just would point out that the federal EPA puts quite a bit of funding into clean water and drinking water SRF monies for the various states. In the past, 20% of that has been earmarked for green infrastructure type of projects. And unfortunately, that is being reduced to 10%. So that's the wrong trend, trending in the wrong direction. So with that, I'm going to start talking about the Old Saybrook project. This is an aerial photograph of a portion of Old Saybrook. It's a town in Connecticut. It's located on the Connecticut River, which is that little water body you see down in the lower left of the slide, and the upper portion of the slide is Long Island Sound. So it's right on the mouth of the river, and it's a area that has had. There's another good picture of the Long Island Sound and the Connecticut River. It's a town that has quite dense development, as you can see from that, somewhere around the neighborhood of 4 to 8 homes per acre. There's a significant nutrient loading issue of moving through the groundwater into Long Island Sound. It consists of older systems. Many of them were built in the 1950s, and they were built prior to the Public Health Code. So they're probably substandard with respect to the current requirements. In addition, a lot of marginal land was developed just due to its proximity to the waterway. And it also has a high groundwater table, which again is unsuitable for on-site septic systems. So there were a number of issues here, and the town was dealing with this with the state for quite a while. Actually, we're trying not to deal with the solution that the state wanted to impose on them, which was the state was proposing that a regional wastewater solution be implemented, where 3 towns would combine and build a major wastewater treatment plant that would discharge into the Connecticut River. The town of Old Saybrook had significant concerns with that solution, not least of which was their worries over such a solution inducing additional development within town and significantly changing the character of the community. So they litigated this for some 20 years with the state, and finally they started a mediation process, and a very unique and innovative decentralized approach was developed.
Hey Virgil, I'm sorry, your audio is still wavering. Just wanted to let you know if there's anything you could do to kind of make it a little more crisp. We're still getting comments on it, so just wanted to let you know. Sorry.
Yeah, well this. Okay, Chris, let me know in another minute or two if it's. I tried a few things here. I apologize about that to everyone. It seemed to work fine during our dry runs earlier. Okay, so keep me posted, Chris.
Yeah, you sound crisp right now.
Okay, good. Some of the key points of the approach was the development and delineation of a wastewater management district, which was a very formal delineation of different neighborhoods within the community that would be subjected to a different set of criteria and rules for managing wastewater issues there. So the additional upgrade standards were established that would be applied just to those properties within the wastewater management district. One of the concerns with any kind of approach like this with the regulators has to do with when you put in alternative treatment type systems, the operation and maintenance of those systems becomes very, very important, and that they be operated correctly so that they function correctly is a real key thing. So there was an O&M plan that would be detailed quite a bit, and as well as the roles of the different stakeholders. We had this town's WPCA, the Water Pollution Control Authority, as well as the local health department, the Connecticut DEP, and as well as the State Department of Health. All those stakeholders had a different interest with the program, so those roles had to be very, very well defined, and that was concluded as part of the ordinance that was ultimately adopted. Also, the DEP had to delegate their authority for the advanced treatment systems, which is something that they did not do happily or readily, but they did do it, and once the appropriate safeguards were implemented as part of the program. And of course, the schedule for planning and implementation was provided as part of the program as well. There were 15 separate focus areas that were incorporated into the wastewater management district. This shows some of them. It included some 1,900 properties, and those were the areas that this wastewater management district applied to. It is so outside of these areas that were outside of the district, just the normal state of Connecticut Department of Health regulations would apply. And so it was very, very specific, and within this area we had a whole different set of rules and regs on wastewater management. These are some of the standards, the upgrade standards that were incorporated into the wastewater management district. I won't go through all of them, but you can see things such as cesspools had to be removed and replaced. That was a fundamental choice or requirement. Septic tanks had to be upgraded to the public health code. And occasionally, effluent filters were required to be added. And the leaching systems would be upgraded to the extent possible, and the set of criteria that was negotiated with the various stakeholders, that if you could achieve between 2/3 or greater than 2/3 of the leaching area that's required by the public health code, then the system was okay, provided it met the certain other criteria. And if the systems, if it didn't meet that, then alternative technologies were required, and they also were required for all waterfront or lots adjacent to a water body. Now this is not just a joke type of flow chart, but this actually was showed the different steps that were involved. So and it relates to the different approvals that were required as when we started from the beginning to getting the different responsible stakeholders to get them to sign off on the program. And so it is somewhat daunting, and a lot of things were required to happen in a certain order. But so I would just advise everyone out there that should you think that you have a application where a wastewater management district type of approach might be appropriate. Just be aware that it is a long process, and it's a challenge to get the buy-in from all of our stakeholders that are involved. And advanced treatment system, what is that? And that was required for some 350 to 400 lots, or what we're estimating will need these. They're basically mini wastewater treatment plants. They provide a higher degree of treatment than a conventional septic system. We had a further requirement, and that required that the system's ATs must reduce nitrates by 50%. And as mentioned, it's a combination of a mechanical process, but principally it's a biological process. They're essentially just wastewater treatment plants on a very small scale, which is a real challenge for them to work consistently, to consistently hit a high level of quality, which is why one of the reasons why we had the very high O&M requirements in the program. Just to show some samples of some of the advanced treatment systems that were considered and are conditionally allowed within the program. Things such as recirculating sand filters, attached growth, which is an attached growth activated sludge type process. We have those three listed: the textile filters, peat filters, and trickling filters. Those are just different kinds of ways for the biological activity to function. They attach right immediately to the media. And we also have suspended growth type of processes that were allowed, and these would be more tanks where the biological growth is in solution. And as mentioned, they're definitely a smaller scale version of a regular conventional wastewater treatment facility. And membrane bioreactors are also allowed. Membrane bioreactors are a very effective way for wastewater treatment, although the energy costs are noticeably higher, and increases the operation and maintenance costs. Just as some examples, this is an example of a attached growth type of wastewater treatment system. There's a photograph there on the upper right of it partially installed in the ground. This is a peat filter. It's partially elevated above the ground, but that can be landscaped. This is just another picture to show some of the covers. Of course, all the action is below ground. That's one of the advantages too with Wade's work there. He has nice photographs of complete streets, and I have to, as wastewater guys, we have all our actions below ground. Important nevertheless. It's a bottomless sand filter, very effective when you have high groundwater levels. And to show some of the landscape components. Looks almost as nice as Wade Streets, don't you think? Okay, I'm going to move now to Greenwood Lake, New York. Actually, it's a lake on the New York-New Jersey border in Orange County. And the particular work that we did was on the New York side of the lake. The lake was experiencing some eutrophication issues from phosphorus, pretty high elevated phosphorus limits. And phosphorus is found in detergents and in human waste. And this was a fairly extensive project. I'm just going to speak to the one portion of it, and that would be the portion that related to upgrading a residential home. So several homes were considered for this, and this particular one is the one that was selected. Some more photos later on. And the objective here was to demonstrate the use of urine separation type of toilets, which is kind of a very foreign idea here in the United States, but it has been done quite a bit in different areas of Europe. And it does make some sense. Urine contains over half of the phosphorus that's found in the waste load. And so if you can separate it at its source, as those bar charts show you, that white portion of the bar chart is the portion of the phosphorus that is found in the liquid portion. And So if you can separate that out prior to it getting into the waste stream, then you can prevent it from getting into the groundwater. So it's a source reduction and separation is certainly an attractive way for wastewater management. So this guy was pretty good in offering his house to actually try and demonstrate some of the toilets. Now, what we have here is a variation on that fine invention of that English gentleman, Thomas Crapper, who truly was a real person. And these are some improvements on his fine device. You'll notice with these toilets that they're that most of them have you'll see like a compartment towards the front, and the intent there is that would capture urine as it enters the toilet, and it will go to a separate system. Fascinating subject, I know. And so they would go to a separate system. It actually goes to a holding tank where it would be pumped out periodically and then removed and brought to a wastewater treatment plant for treatment and disposal. So in this case here, you can see where the yellow dashed line shows the approximate pipe location, the buried pipe, and then it's the 1,500-gallon fiberglass tank that would hold the diverted flow. And so it takes takes quite a bit of modification. This is the view from down below from the basement, and there needs to be obviously a separate piping system to take the urine flow and take it out separate from the rest of the waste flow from the toilet facilities. So this is what you're seeing here. It is, as I mentioned, some additional work is required for that. And it definitely gets you into some crowded plumbing down your basement. And these are actual pictures of the first and second floor bathrooms that were installed, and you can see the little shelf that's in the toilet for capturing the urine and doing the diversion. So that's an after picture. You see the tank is shown there in the upper picture. Just a really nice way of reducing phosphorus load. Okay, so going from on-site types of applications, looking at wastewater treatment now. And there are some very significant ways to implement some green infrastructure with wastewater treatment, or certainly to get into some sustainable types of practices that are not traditional, or not things that we have traditionally implemented with our wastewater treatment facilities across the nation. There's opportunities with nitrogen and phosphorus. These two are being implemented on selected areas on a more limited basis. It's becoming more and more common. There's been a nitrogen removal program here in Connecticut, and for some probably 10 years now, 10, 15 years, and in other areas where different water bodies, nitrogen is a major issue. And I'll talk some more about that. But there's also process enhancements that can be done within the treatment process itself that would allow us to reduce our carbon footprint from these plants. There's a lot of carbon within wastewater, and a lot of it is currently just trucked away. And so there's been certain plants that we've been involved in that we've been maximizing the use of capturing that carbon and using it elsewhere within the treatment process. So this will help you improve your effluent quality with the suspended solids and with nitrogen and phosphorus. It can reduce energy consumption at the plant, and it can reduce chemical use. So instead of doing treatment via chemicals, you can do it via biological actions, which reduces the cost. You don't have to buy these. You don't have to buy the treatment facilities for adding chemicals, and you use less chemicals, and you also have less material that has to be disposed of, which is another cost that can be reduced. So looking at nitrogen, this is something that we can do through a biological process, and it's released as a nitrogen gas. It's a very harmless gas. It's 80% or so of the air we breathe, I believe. And through this process, it recovers by doing the nitrification, denitrification process. We are able to recover oxygen, dissolved oxygen, and alkalinity. So it actually helps to reduce some of the costs for operating the plant itself. And it's a very modest capital cost to reach levels in the 5 to 8 milligram per liter range, which is a significant improvement for most treatment plants. Most plants, the effluent nitrogen would be in the 15 or so parts per million range. So without a lot of cost, we can bring the nitrogen down to a pretty decent level, and then we can also save some costs by doing that. The energy use is reduced as well through less oxygen has to be pumped in to do the treatment. There's a picture there of a treatment plant here in Groton that where it does nitrogen removal down to those levels. There's actually, if you look in the, you see in the center there, there's three rectangular tanks right in the middle. The 2 tanks to the bottom are the 2 tanks that are online, and there is the left-hand portion of those tanks is darker, and the right-hand portion is lighter. That left-hand portion is where the nitrogen is actually being removed. With respect to phosphorus, it's a nutrient that's becoming more and more the focus of removal for wastewater treatment facilities. And there's a choice here again, as with nitrogen, where you can remove it either chemically or biologically. And the biological process is definitely superior to chemical precipitation in that you use less chemical and you generate less solid material that needs to be removed from the site. And you're also able to use some of the additional carbon that remains on site in the process. So one of the ways we do this is we will take the waste solids, and we will generate volatile fatty acids in those tanks through a fermentation process, and then we take that liquid off of that and we introduce it into the head of the treatment process, and that is able to help reduce the phosphorus. And then the phosphorus will settle out in our settling tanks, and that can be used to create fertilizers and other products. As I said, the chemical addition is costly, and it's costly on an operational basis. So every day chemicals have to be added. Every day solids are being settled out that contain these phosphorus compounds, and you can't do anything with them other than landfill, or in some places they incinerate those. So it's not the preferred way to go, and it also consumes more of the carbon that otherwise would not be consumed at the treatment facility. Opportunities for renewable energy in our treatment facilities. An important point to note is that nationally, the energy that's consumed to operate wastewater treatment plants is estimated by EPA at 3% of the total energy used in the USA, which is a pretty big number. So if your town has a treatment plant, that treatment plant represents 1/4 to 1/3 of the power consumption of your town. So if there's anything we can do there to reduce that energy cost, then it's a huge benefit. And here in Connecticut, we have some of the highest electric rates in the nation, so it certainly is a goal. That's something that we want to do. But this is important anywhere, no matter what state you are in. And one of the ways we do it is through doing some things with the digesters. I took those 2 blue tanks you see here are, and the way this works is, if you see in that diagram I have, there is in the middle it shows the anaerobic digester, and we can turn this. That's the tank where the waste solids are sent. We digest those solids, and they create methane gas, which we then would condition, which means clean up the impurities in it that come from the process, and then that gas would be used to fire either a micro turbine or some kind of engine, And from that engine, we would generate a generator and create electricity, which could be used back in the facility to reduce their energy that they need to purchase from the public utility. Now, we call this combined heat and power, CHP. We actually would take, we're not done with it at that point. We take the exhaust gas from the engine or the turbine, and then we recover that heat within that gas, and we use that heat to either cool, either to run it through a boiler, where we could then use that heat and to heat one of the buildings within the treatment facility itself, or we could use that to preheat the solids that would be going into the anaerobic digester to preheat that as it goes in to actually kind of supercharge the whole process, and it allows us to recover a significant amount of the energy that would otherwise just be land disposed of or incinerated. Other options at treatment plants, I don't have photographs for these, but there's a lot of water moving around at treatment facilities, and so there's things such as that are being piloted at different plants of putting inline hydro type of power generators where there's sufficient elevation drop for to run those. And other facilities, some facilities are in very urban areas. Others, though, if they're in their appropriate location, they're good candidates for investigating either putting in solar panels or wind turbines. So that takes us through the treatment plant. We talked about decentralized or non-centralized type of practices. There are some issues or opportunities for wastewater disposal that should be looked at or should be considered, and that are getting more and more consideration and application in recent years. Reuse is a good one. Non-potable, it can be used in non-potable uses. A purple pipe, which means a separate system that carries a non-potable type of water, can be used in like a small, or not even small, but in a commercial development for flushing toilet water, that kind of thing. It's been used as irrigation. That's one of the pictures we see down below. Or for cooling water for an industrial application, such as a facility that needs to take in cooling water rather than bringing in water from a river. If it's located, it can be sited so it's near the wastewater treatment facility, then effluent water coming out of the plant can be used as cooling water in the industry rather than taking in clean water. There's a couple applications like that we're assisting a town with right now here in Connecticut with an energy recovery facility. And then another option to do is to not even have a point source discharge of your treated wastewater. Do things such as spray irrigation, which actually is what that photograph on the bottom is. That's not an irrigation such as you would use at a golf course. But that's spray irrigation, where you would apply a couple inches, say, of effluent during the growing season to a large field, and that would be how you dispose of it. You need to have a very large holding basin to hold the wastewater when you can't always discharge, such as here in the Northeast. During the winter months, you would not be able to do spray irrigation, but so you would need a fairly large facility, such as which is pictured in the bottom right, to hold the wastewater while that is until the springtime came. But other areas of the country, that wouldn't be a restriction. And if you have a site with appropriate geologic characteristics, you could use something such as a rapid infiltration basin. The one pictured here in the upper right is from New Hampshire, and these are basins that have a very good soil beneath them, and you're able to put a fairly large volume of water fairly quickly into the ground. So you just need to look for where you have the appropriate conditions, and these alternative disposal methods might be appropriate. And then low impact design in wastewater. How do you do that? That's a good question. Because wastewater is not stormwater, so but there are opportunities for stormwater management LID in wastewater. There's a project here in Connecticut, the Hartford Green Capitals Demonstration Project was a $1 million project that was paid for by the Connecticut DEP Clean Water Fund, which is their Clean Water SRF, and it was applied to the roof leaders and that were connected into the sanitary sewer system. So Hartford is a city that has a combined sewer system. So rainwater is typically entered into the sewer system, the sanitary sewer system. And so during times of very high rainfall, the combined system can't handle the flow, so it will discharge a combined sewer material directly into the rivers, which is obviously a very bad practice, but many of our older cities have combined systems, and so they need to figure out a way to manage these CSOs. So this is using LID has some opportunities for application. It won't be in every case, but this was a great demonstration project. And some of the things that they used here at the Capitol were porous pavement, which you can see going around clockwise on the photographs. Is porous pavement, rainwater harvesting. That tank that's being loaded in is essentially a large cistern. It was equipped with pumps for pumping the rainwater out. Afterwards, they're using irrigation. Then a rain garden down below in the lower right, and then a green roof was also used as well. So as I mentioned, this can be used in some as part of the tools in our tool bag for dealing with the separation of combined sewer overflows, as well as for what we call infiltration and inflow management. Many of the older collection systems, wastewater collection systems, even though they are separate systems and were not intentionally built to carry stormwater, they do leak quite a bit. A lot of roof leaders and such things, storm drains are connected in. Just the joints are old and cracked and allow groundwater to leak in. So when we abate those types of problems, we could also use LID in those kinds of solutions within certain cases should the parameters work. So wraps up my presentation, and this is the speaker contact info. Hopefully everyone was able to hear me. I apologize for the technical difficulties.
Thank you, Virgil. I appreciate that. Yeah, you could actually, if you could keep that last slide up. If you could keep that last slide up as a full screen.
Okay.
And I'll begin the question and answer session. So yeah, thank you for everyone who, thanks to all who remained on the line during the presentations. We will begin the question and answer session right now. So the first question that came in was from Paul Larson. Some states, particularly in the West, have laws regarding water rights that prohibit rain barrels, such as the ones described in the presentation. Have the presenters experienced this issue, and if so, how has it been dealt with?
We did not have an issue with that at all. Amy may want to jump in here for a second.
Yeah, in New Jersey, it is legal to harvest your rainwater. Water that's falling on your property does belong to the owner of that property. I understand there's a major issue out in the West with very dry conditions and the Colorado River drying up and things like that, and how the state of Colorado has actually reversed itself on allowing rainwater harvesting. I know it's an issue, but in New Jersey we typically get about 44 inches of rainfall per year, and so currently there's no water rights issues in New Jersey.
All right. This next question came along from James Garofalo. What was help given in rain barrel installation, and how do the rain barrels hold up in the cold?
Okay, actually, we were not helping people install them. They came with instructions, And because of the cold weather, you do have to winterize your barrel, which means you have to disconnect it, take it, you know, turn it upside down or bring it in the garage, because if they freeze with water in them, they can crack and then they'll be unusable.
All right. Were suburban, this question comes from Cheryl Usher, were suburban roof gutters generally connected to storm or combined systems, or sheet runoff from lawns and driveways?
For the rain barrels, the downspouts were disconnected from. Some of them were connected directly to the storm sewer system, but many of them were just going onto the lawns.
Right. The homeowners shortened them so that they would, instead of going down into the lawn, they would go just as far as the rain barrel.
Okay. The next question comes from Colleen Roberts.
Is that in?
Oh, I'm sorry. Sorry if I did I jump the gun on that?
No, I think there was something in that question about combined systems, and the only combined sewer system that we're aware of was in Patterson.
Okay. Well, was that a question, or is that?
That was, I think, in response to that last question.
Oh, okay. Okay.
About downspouts combined CSOs.
Oh, okay. Cool. All right. The next question comes from Colleen Roberts. What's the average annual rainfall in the area of New Jersey where the rain barrels were distributed? Also, what are New Jersey's laws regarding homeowner rights to rainwater collection? In Colorado, homeowners don't own rainwater that falls on our properties, and it's technically illegal to collect it. The state is looking into what the effects to our water system would be if pilot programs were allowed for homeowner rainwater collection. I imagine this is a bigger issue for arid areas out west than on the East Coast.
Yes, this question was actually just addressed. We do get about 44 inches of rainfall in New Jersey, although last year was an anomaly with about 65 inches per year. But there is no water rights issue in New Jersey, and I don't think there are any along most of the East Coast. In New Jersey specifically, people are being encouraged to reduce stormwater loadings to the sewer systems, so that's why we're implementing all of these water best management practices like rainwater harvesting, rain gardens to capture stormwater. So we actually have the opposite problem of the West, where there's too much runoff entering the waterways and entering the sewer system.
Okay, so the next question comes from Ellen Mai Galloway. As planners, these projects discussions of green infrastructure is pretty standard, more innovative than decades ago, surely, but generally accepted as best management practices. What about engineers? The traffic engineer describes himself as a complete streets engineer. In our local government, the engineers are not necessarily turned into complete streets, and is a constant fight for planners to convince them that roads move people, not just cars. Any trends in education going on in professional engineering organizations?
Yeah, and Chris, I can start to address that, and if anybody else wants to chime in, they certainly can. One of the things that we're starting to see is actually directives from top-down government that actually require the engineering community at the municipal and state level to design facilities with regard to complete streets. Many states have adopted complete streets policies. Many of them have also amended design guidelines to be able to allow their engineers to design complete streets. As with anything, the education has been one of the keys. And as more of these projects are getting on the ground, there's more case studies that can be pointed to start to alleviate some of the concerns in the engineering community about how certain things work and mixing traffic, mixing vehicular traffic with non-motorized traffic. So if I had to say the way that a lot of them are getting done, it's not necessarily coming from inside the engineering community, although ITE did collaborate with the Congress for New Urbanism in developing the recommended practice for walkable urban thoroughfares. But a lot of it is coming from the more of a political end, with states and municipalities saying, we're going to do this, we're going to build complete streets, and that is therefore our policy. Some of the other places that we see education coming from are with local and state APA and Congress for New Urbanism chapters. Michigan has been very successful in doing that. They have a statewide transportation bonanza every year in which they bring in speakers and invite all of the Michigan DOT and local engineers to participate. In Connecticut, the state Main Streets program has been at the forefront of the movement, and in Rhode Island, one of the smart growth organizations, Smart Growth Rhode Island, has been sponsoring a series of work sessions on complete streets for education for the engineering community as well.
Yeah, and can I just add that the American Society for Civil Engineers has had, I think they're going on their 6th or 7th biannual conference specifically on low-impact development. They just had one this past fall in Philadelphia, and it's growing every year in terms of attendance, and there are lots of sessions just on complete streets, green streets, case studies, bioretention, permeable pavement. There's quite a big movement in the Civil Engineering Society that is already onto this, and those conferences also provide lots of professional education workshops and pre-conference workshops to educate people separately from the design studies and the academic papers that are presented.
Yeah, this is Kathleen. I believe that the New Jersey Department of Transportation has adopted complete streets, and as well as Passaic County.
Mm-hmm.
Okay, so moving on to the next question. Susan Poplin asks, what are some recommendations to maintain rain gardens in drought conditions?
Certainly when rain gardens are first installed, they will need irrigation until the plants get established. But over time, you will need to water less and less because the plants will be more established. They will have the very deep roots. They will be more drought tolerant. We do recommend that you plant plants that are drought tolerant and wet tolerant, just because in any rain garden both conditions will exist. So there's really nothing specific that you need to do in terms of a drought. You just need to keep an eye on the plants, and if they do look dry, you may need to irrigate, which is counterintuitive, but you may need to do that during particularly dry times.
Just a personal story here. I have taken a bucket into the shower with me during drought conditions. I live in an area where we have private wells, and sometimes we're on water restrictions, so I take a bucket in the shower and then I'll water my garden with it.
Okay, the next question, with 2 million gallons, this comes from James Garofalo, with 2 million gallons seeming high, assuming 10-month use, that's 333 gallons per month. How do you determine who gets them? And by them, I'm assuming that he means rain barrels.
As far as who gets them, these were limited to people that were identified in the Molly Ann Brook watershed. That was what the grant stipulated. As far as the 2 million gallons, I'm going to let Amy jump in there.
Yeah, that number was actually a very conservative estimate based on a typical water usage of barrels that would be capturing rainwater. In New Jersey, we have a typical 2-day dry period between storm events, so that was taken into account. The number of precipitation events per year during the periods of use, so let's just say April to October was what I used for that calculation. That's typically when people use their rain barrels. And then each rain barrel can only capture 50 gallons per, well, 50 gallons per storm before it overflows, just because the overflow isn't at the very top of the 55-gallon drum. And so all of those calculations were actually rather conservative, and they were based on actual rainfall numbers in New Jersey in this area. And I can forward those calculations if the respondent would like to see those.
All right, so our next question comes from Michael Broussard. Are regulations in place or public education materials made available to address the use of pesticides and fertilizers on rain gardens, or is the use of native plant materials suggested to limit the use of these potentially hazardous materials?
Yeah, native, we always try to use native species. There's also a new fertilizer law in New Jersey, but we do not encourage any fertilizer or pesticide use in rain gardens for obvious reasons.
There are some clauses in the state that you can use fertilizer if a soil test shows that it's necessary for the plants to grow, but people are usually not willing to undertake that burden. That's something that's new in the state fertilizer law. So it's really just better to not use fertilizer. That's what we recommend.
This is Jim Riordan, and having looked at standards for rain garden maintenance and bioretention maintenance around the country, that's pretty much the same in other states and other localities. The idea is to try and discourage the use of fertilizers and pesticides because of the potential for water quality problems associated with them.
All right, this next question comes from Janet Rausch. Can any of the speakers recommend a green infrastructure / site planning book that goes over these different best practices? For example, rain gardens, RSFs, LIDs, low impact development, so on and so forth.
Absolutely. There are certainly a number of them out there. The first place I would recommend looking is perhaps your own state stormwater manual. If that does not incorporate low impact development, or you would like additional information, the Connecticut manual that I referenced earlier has a lot of good information in it. If you guys don't mind my hawking the manual that I put together. Additionally, there are quite a number of good manuals out there from states of Washington, Maryland, where low-impact development really first came into being. New Jersey has a great manual. There are really a number of them.
I would check the APA library bookstore. I'm sure there's a few in there.
Yeah, and you can also find resources at the EPA, the Environmental Protection Agency's Green Infrastructure website. They also have a database with case studies for each type of best management practice and LID, and it also shows pollutant removal efficiency if that's something that you're concerned with regard to water quality.
Okay, this next one comes, I'm sorry, was someone else about to chime in? Okay, this next one comes from Armando Perez. Mr. Lloyd, about separation of urine and feces, could you summarize what treatment processes are used for each, and how does this separation reduce costs?
Good question. It doesn't reduce the cost right off the bat. It's not done as a cost reduction or cost savings measure. It's done for the objective of trying to improve the water quality of the lake. There is no on-site treatment for phosphorus that's done with this approach. It's the urine is separated to a separate whole tank, where it's periodically removed, and it would be taken to a wastewater treatment facility, where the phosphorus would be treated there. The way it's treated is you have a small compartment in the beginning of the treatment process. It's an anaerobic process, so there'd be a total absence of any dissolved oxygen within that compartment. And then in the presence of some volatile fatty acids that you can create from the waste solids at the facility, you remove you break the bond and remove the phosphorus out that way. And then the solids that go the other direction from those urine diversion toilet, that would go into the septic system, into the septic tank, and then the gray water would go out to the leach field. So it would be in a kind of a standard leach field type of treatment system. If you do need to get to very low levels of phosphorus, you would, at a treatment plant, they would put like a filter on the end of that treatment process.
Okay, this next question comes from Peter Smith. How much of the 2 million gallons diverted to rain barrels was estimated to outfall to Molly Ann Brook? What's the annual flow in the brook?
You know, I don't know off the top of my head. That's a good question. I would point Peter to the watershed management plan. I'm looking through here quickly, but I don't see that. I could get back to you, Peter, or you could check out the management plan online.
Okay, we're down to actually our last question of the afternoon. This comes from Kathleen Cherry. What kind of maintenance is expected from the homeowner for typical advanced treatment? What is the cost of maintenance, and how long do these systems typically last without major renovation?
I guess that. Oh, I'm sorry. I was. Yeah. This is Virgil Lloyd. The advanced treatment systems. One of the biggest challenges with those advanced treatment systems is having generally a continuous flow to the system. These are normally processes that are accomplished through bacterial reactions. So the bacteria, to keep a healthy population of bacteria, you need to have a fairly consistent flow of wastewater into the facility. So the maintenance chiefly consists of either recycling pumps and then removing of waste solids from the bottom of these facilities on some periodic basis. And email me with that if you want to follow up that question. I know we're getting low on time, and I could get into that in more detail.
Okay, so yeah, with that said, we're actually gonna have to wrap it up. Virgil, if you could actually just switch the screen over to me. I'm gonna do some last-minute housekeeping business regarding people's CMs. And I'm sure everyone's looking at my background.
Lovely.
All right, so just a reminder, to log your CM credits for attending today's webcast, please go to www.planning.org/CM, select today's date, April 13th, and then select today's webcast, which is Opportunities in Complete Streets and Green Infrastructure. Once again, this webcast is available for 2 CM credits. Today's webcast is being recorded. Come Monday, we will have a 6-slide per page PDF along with the recording available at www.utah-apa.org www.ccc.org/webcast-archive. Thank you all for, I'd like to thank my speakers. I'd like to thank our speakers for this wonderful presentation this afternoon. And thank you all again for attending. Everyone
Hey, Chris,
Yes.
before you sign off, can you please forward me the announcement for this webinar?
The announcement?
That went out, I guess, through the APA?
Yes, I could do that.
It's Kathleen here.
Yes, Kathleen, I will do that.
Thank you, Chris.
No problem at all.
Thanks, everybody. It was great.
Thank you very much, Chris.
No problem. Thank you. Thank you very much, APA Connecticut. And of course, thanks Passaic County.
You're welcome. Thank you for hosting us.
All right.
My pleasure.
Chris, are we we're not broadcasting anymore?
Oh, we're broadcasting. All right. I'm actually gonna stop the broadcast right now. So everyone have a nice weekend.
You too, Chris. Take care. Take care, Jim, Virgil, Wade. Be well.
You guys too, Kathleen, Amy. See you guys.